Let's look at number 11, and got a rock that's been thrown upward from a bridge. The bridge is 20 feet above the surface of the lake. It reaches its maximum height above the surface of the lake 0.25 seconds after it is thrown, and then it reaches the surface of the lake 1.5 seconds after it was thrown. So now we're supposed to define a quadratic function that gives the height of the rock above the surface of the lake in feet in terms of the number of seconds elapsed since the rock was thrown. So you should know this from the homework. When it reaches its maximum, that's sort of halfway between the two x-intercepts. When it hits the surface of the lake, that we would assume our graph is set up with the level of the lake being y equals 0, the x-axis. So what we've got going on here is it's thrown off a bridge. We're 20 feet high. It goes up and then comes down. And what we know is that this happens when it hits the water at 1.5. It's at its high point at 0.25. And that's going to help us get this other sort of erroneous where the other x-intercept would have been, right? Because we're on this bridge throwing it. We know that is the bridge is when x is 0, time of 0, the rock is 20 feet in the air because it's on the bridge. Now, you might argue, well, if I'm on the bridge and the 6-foot man is throwing, or woman, 6-foot person, then isn't it really 26 feet? Or if I'm a 5-foot, that's what I am, right? I'm not quite 6 foot. I'm 5'10". Anyway, it's a little bit above 20 feet, but we'll just use it. That's what they gave us. They didn't tell us the height of the person. I guess that would make it a little bit more realistic and a little bit more complicated. But anyway, that's our y-intercept, 0, 20. That's what we're going to use. So we just need to find what this would be. And so what we can do is we choose something here. Is we need this distance between 0.25 and 1.25, and so we subtract 1.5. Sorry, 1.5 minus 0.25. When you do that, you see you're going to get 1.25. So that's the distance. So what we have to do is from here to here is 1.25. Well, there's 0.25, so this must happen here at -1. My arrow, I'll just turn it into a -1. So we've got two x-intercepts. We've got an x-intercept at -1, which, remember, that gives us a +1 here in our factor, because when you put in -1, -1 plus 1 becomes 0. The other factor we have is at x and 1.5, and since it's a positive 1.5, we need to have a negative here. Right? Because when we plug in 1.5, we're going to get our 0. 1.5 minus 1.5 is 0. Okay, so that's how our function is going to look, and that's what we're trying to find, right? We're trying to define this function. We did this earlier with another polynomial. The only thing we're missing is that there's some coefficient that could be in front, and so we'll call that a. And remember, the way we figure out what this constant is, this number a, is we have to use one other point. And a very nice point to use is the y-intercept. We plug in 0. We know that for x, we know that the answer is going to be 20. So let's go ahead and do that. So we know that we will have 20. We don't know what a is yet, but we will get there when x is 0. So we have 0 plus 1. And then we've got 0 minus 1.5. So the math ends up being fairly nice here. We're going to get 20 equals a. This first one is going to be 1. And then the second one's a negative 1.5. When you multiply 1 times negative 1.5, you end up with negative 1.5. And so we divide both sides by negative 1.5. So that cancels, and we're going to get that a equals I could kind of guess, but why don't we just plug it in and we'll see what we end up with. So 20 divided by, now this is a key part. I want a negative 1.5. That's where I use this one. This is a negative number. If I use this one, it's going to want to subtract. Probably gives me a syntax error. In fact, it does. Negative 1.5 is negative 13.33. So we could use that. Or another thing we could do is we could to kind of make it, keep it as a fraction, you could multiply the denominator by 10, which moves it to 15, and then that would be 200. So we could end up with another way to write this. Let's get the pen. You could write this as 200 minus 200, right? Over 150. So multiply the top and bottom by 10. Again, that would reduce, wait, not 150. Sorry. 15. Oops, let's erase. I'm trying to be just like so. So I moved that over, that's 15. Top becomes 200. I suppose we could reduce that because 5 can go into both of those. 5 goes into 240 times. 5 goes into that 3 times. And then we have our x plus 1 and x minus 1.5. Well, sorry. I'm trying to do two things at once, aren't I? So that's our A. What I just wrote down here would be the full function f of x equals negative 40 over 3 x plus 1 x minus 1.5. That's our function. Notice it's negative because it's concave down, so that might be helpful. And we'll get a square quadratic.